Right, it's a few minutes past, so I guess let's kick things off. Anybody that misses anything at the start will be recording and sending it round anyway. So yeah, thanks for everybody for joining us today. It's good to see some new names attending, as well as some of those that attended our last Kotlin session as well. As a very brief introduction, Source Technology are a fast-growing tech recruitment agency. We started Source Talks to offer a platform for knowledge sharing across our specialist areas. I've recruited into the JVM market for the last 6 years. In the last year or so, we've seen a real uptick in demand for Kotlin on server-side projects. So given the excitement building within our network, we decided to kick off the Transition into Kotlin series, where we'll be holding monthly talks exploring different aspects of the language. Our first session with Jason Chow from 11FS gave a really good overview of the benefits of using Kotlin, key frameworks available, and a kind of high-level view of the end-to-end considerations when making the transition. Whereas today we'll be getting a little bit more technical and exploring the nullable types feature within Kotlin. So we're excited to be joined by Nat Pryce and Duncan McGregor, two experienced server-side Kotlin developers who, as well as being regular speakers on Kotlin conferences, you might also see from Nat's background, they have quite literally written the book on Kotlin. Please do drop any questions in the box as we go. We probably won't have a chance to answer them as we go, but we'll definitely try and allow some time afterwards to answer questions. So Duncan and Nat, thanks again, and yeah, over to you.
Thank you.
Woohoo.
All right, so yeah, I'm Nat, this is Duncan. We're authors of the book Java to Kotlin, a refactoring guidebook that I hope you can see the cover on your screen. One of the most, I think, exciting features of Kotlin for Java developers is its Null Safety. That is, it tracks nullability of references in its type system, which makes it a lot easier to, well, a lot safer to use null, and a lot of patterns you'd use in Java to deal with sort of optionality can now be handled in the language, and it has language support as well. So we're going to look at that today. We'll look at some code, we'll do some refactoring. Our book is about how you can transition a code base from Java into Kotlin and take advantage of Kotlin's features to write not just Java and Kotlin syntax, but actually idiomatic Kotlin that takes full advantage of the language and features in the language that are not in Java, while maintaining and continuing to maintain like business critical features in both languages. So we've had experience doing that ourselves and found that introducing Kotlin into an existing code base allowed us to deliver faster and faster as we spread Kotlin further and further throughout the code base. And that's what our book is about, techniques for doing that. So we're focused today particularly on nullability and how we can take advantage of that. Let's have a look at what we're going to talk about. So null, what is it good for? It's there to represent the fact that you've got a reference that to something that might not be there, right? So maybe you've looked up something in a database and not found a result, so you'd return a null. Maybe there's a calculation that can't compute a result, maybe like, for example, taking the first of an empty list, there isn't a first one, so you might return null. Or because in your actual domain model, the concept that you want to represent is itself optional. I don't know, like a house name, for example, in an address. Not all houses have names, so you would have a null for houses that don't have a name. And depending on the context in which you're using a null, right, you're going to do different things with that optional value to recover from the fact that it's not there, or to process or react to the fact that it's not there. And as we look at the code, we'll talk about those. So what's the problem with null, particularly in Java, but also other languages, is the main problem is that it's a hole in the type system. Right? The type system represents like types, classes, and the methods that you can invoke on those classes. But if you end up with a null reference, you try and invoke a method, right, you get a null pointer exception, a crash at runtime, and the type system has not detected that you're calling an operation that you can't actually perform at runtime. Tony Hoyle, who invented the null concept in Algol back in the 1960s, calls it his billion-dollar mistake because of the number of production errors that having that hole in the type system has caused, right? And it also makes code hard to understand. If every reference can potentially be null, we can't tell which ones are actually meant to be null and which ones are not, which concepts in our code are optional and which ones are always meant to be there. So what do we do? What do we do about it in Java? We could check every single null reference or every net reference for nullness before we dereference it. But in practice, that's just too much work and makes the code unreadable. We could never allow null in our Java code at all. This requires a lot of discipline. I have worked on systems where that was our rule. We never allowed null in the code. It was great. There was no null pointer exceptions. But it was a lot of work, and we had to make decisions about the libraries that we depended on. If libraries could return or take null, then they didn't follow those rules, and so we'd either not use them, which was a bit annoying if it's a very popular library, or we had to wrap them in a type safe layer that we heavily tested to make sure that on our side there was no nulls, and on the other side there was a translation in between nullness or not. Maybe we use some naming conventions in our code. Rather than not allowing null anywhere in the code, we have some naming conventions that allow us to, at least as humans, identify which references could or could not be null. We have naming conventions like, I don't know, address or null, or house name or null, maybe house name, something like that, which is helpful for us to understand, but the machine isn't checking it for us. It still allows us to accidentally pass a null reference where one is not expected. And so it's just a sort of sticking plaster over the problem, really. JSR 305 introduced nullable and non-null annotations, which certainly help. The IDEs and compiler can then check if a reference that's annotated as nullable is being invoked without a null check. However, we can't annotate everything that we might want to. For example, I can say that I've got a nullable list of strings using generics. But you can't say I've got a non-null list of nullable strings, because Java doesn't allow us to annotate a type that we're passing in as a generic type parameter, but actually collections, that's often where you want to be able to have nulls and collections and things like that, especially during sort of functional processing patterns. And so we can't use annotations to really tighten up our checking automatically. We could use a null object pattern. Remind me later. I told you that I wasn't in charge of my Mac. We could use a null object pattern. The null object pattern is if you do have a polymorphic interface, you can, and it makes sense to do so, you can have an implementation of that interface that acts like a null. It doesn't do anything when you call that interface. And anywhere that you want to represent the lack of something, you pass in a null object, a null implementation of that interface, and then you never have null references. You just invoke polymorphic methods, and they just do nothing where appropriate. Works very well in OO designs, but it's not a very widely known pattern. So there's often some work to do to make sure that people understand what's happening inside the code base. It's not, for example, it's not in the famous Gang of Four design patterns book. So what I see most commonly in industrial code is just ignore the problem and hope it never happens. But in practice, it does. So often you end up with null pointer exceptions in log files, and then trawling through logs and working with a debugger to try and find out where a null reference has appeared in your system and flowed through to where it actually then ends up causing a crash, which is the billion-dollar problem. And in Java 8 and above, we can use the optional class, which was introduced to represent the optionality. So an optional value is it's like a container of 1 or 0 values, represents the presence or absence of a value. Other languages have something similar. Haskell and Scala, for example, make good use of this. And the benefit of the optional class is that it not just represents like a absence or presence, but it actually has operations that allow you to apply functions to transform that optional value, map it to another optional value, without actually doing the if statements yourself. So it actually provides these higher level operations that avoid lots of nested conditionals. There's some weird restrictions that were originally documented about how it's expected to be used, but certainly in the teams that I was with, most people ignored them because actually it was just too useful a class not to use it for your domain modeling. So we're going to look at how we transform Java code and Java 8 and above code that uses the optional class into Kotlin, which has, because it tracks nullability in the type system, doesn't need to use it. Right? So how do we gradually move our code over using the IDE's automatic refactoring tools, and what benefits do we get? Right. Shall we look at some code?
Exhausted
Duncan,
just from listening to you. Okay,
which class should I open?
I think you should open leg. So this is a fictional code base that we sort of run through in our book, and the fiction is that there is a travel planning application. So planning journeys from one place to another, because we were planning the journey from Java to Kotlin. And in this case, we're starting with the idea of a leg, and a leg is a piece of a journey. And it might have lots of other fields, but here you can see it's got some sort of planned start and end time, some sort of description, and you can calculate how long it's planned that a leg should take by subtracting between the start and the end. This is already Kotlin, so it's quite nicely small, but code that uses it, we've got Java code that uses it, and let's have a look at that in legs. So legs is, we think, pretty typical Java utility code, if you like, and find longest leg over is used in a piece of the system that is looking at journeys and trying to work out how to make them better for you. So it might say, well, any leg of a journey that's over 24 hours, then we let's find the longest one of those in order that we can try and find a better bit of that route for you, or put you up in a hotel or something. And you can see here that it operates on a list of leg called legs, and it has a duration that it's comparing these two. And the problem with find longest leg over from sort of nullability perspective is that it may not be able to return a result. So it may not be able to return a result for one of two reasons. Either the list of legs is empty, so what is the longest leg in no legs? Well, the answer is, I don't know, null, basically. Or in this case, optional of empty. Optional empty. Alternatively, there may be legs, but none of them are actually over the specified duration. And if you look at the algorithm, it's a bit imperative. It's actually sort of looping over things. We might or might not write it like this, but we have. And it's a reasonably typical Java pattern that we allow null inside this method in leg, but we communicate outside the method with optional. So we do everything in terms of the leg that might be null inside, and then at the outside, at the border, we say, let's marshal that into an optional. Right, should we go and look at the tests? And these tests, they're here really to give us an opportunity to refactor, but they're also random splendid. They're not a bad set of tests, really. They show what happens. So the first one shows that if we have no legs, we call this code on the empty list, then we get optional empty. That's true when none of the legs are long enough as well. And in these other cases, we have something, we have a leg to return, but we have to deal with it in some sort of way. So we have to unwrap the optional. And there are two ways we show to unwrap the optional here. One is this or else throw, which says, if it was the case that we didn't find a leg, then we would throw, in this case, an exception. And the other way we do it is to take the optional and map something to it. And then, so in this case, we are looking inside the optional and saying, cool, get description on that. Otherwise, do something else. And in this case, do something else is no leg found. So this is an example of we couldn't find the thing that we wanted, so we're substituting something else at runtime. All right. So this is Java to Kotlin. So we want to convert something to Kotlin because it's, we like Kotlin. That's what we're here for. And what we're going to do is we're going to convert this legs class to Kotlin, but we're going to leave longest leg over tests as Java, so you can see that everything works well, continues to work. So we are going to, what is Nat doing?
I was trying to find the convert to Kotlin.
No,
But,
you just Command Shift, Shift Alt Command K. Splendid. So IntelliJ has a tooling to convert Java files directly to Kotlin. It offers to fix up other files to make them work. In this case, it should need to do neither. So let's just say yes to that. That will do. It has a thing to convert Java to Kotlin, but it doesn't work all the time. And in this case, it's messed up the imports, but a little bit of alt entering will fix that. And let's run the tests. Oh, that was a surprise. So you can see that our Java tests still work, despite the fact that legs is now in Kotlin, which is nice. And in fact, if we look at legs at the test, you'll find that it hasn't changed at all. So we could keep all of our Java code exactly as it was, and still convert bits of our code base to Kotlin. In this case, we've converted legs. This is not very idiomatic Kotlin, though. It's got this odd object and odd JVM static thing going on. So we might want to move this out into a top-level function because Kotlin supports top-level functions. Alt enter on that will do it. Well, I say it'll do it. Once again, the tooling, not completely perfect and breaks a little bit. What's actually happened is that it's broken because it hasn't moved this private function, private method with it. So let's just pull that out as well. And that will do a little bit of fixing up. Yep, delete that. And we can now run the test again. If we go and look at the test this time, though, they have actually had to change longest leg over tests. And the only change is where we import it from. So previously, that import static on line 15 had said travelator legs, and now it's legs.kt. And that's because Kotlin's had to invent a class to hold this static. That's not very convenient to us, so we'll revert that little change there. As if we had a large code base, and we can go and fix up this file to tell Kotlin what we'd like that name of that file to be, name of that class to be, and it was previously legs. So with a little bit of magic, we can tell it that actually legs would be better for us. And this allows us to have this more idiomatic Kotlin of a top-level function, but still integrating with Java well. If we run the tests again, you'll see that passes, and the tests are back to where they were. So again, none of our Java code has changed.
So there we did, a bit of manual patch up. If you had a much bigger code base, you would probably not want to go and revert all of those little changes. But when that convert Kotlin dialog pops up, you can ask it not to do those changes and not affect the other files, and then apply the @JVM name annotation, and then everything will compile again.
This is still not yet really very idiomatic Kotlin. We'll come back to some of those changes, but this actually, no, first of all, let's just have a little look at what we have. Line 11 is interesting. Line 11, you'll see this leg question mark. And question mark is the way that Kotlin marks a type as optional. So nothing has changed about leg, but what we're saying is that the type of this pointer is not just leg, it's a leg that might be null. If we remove the question mark from there, then we couldn't assign null to it. The compiler says, oh, well, hold on a minute, you've got this thing. If you just say leg, that means it can't be null, but you've assigned null to it. So something wrong here, I won't compile. Putting the question mark back in.
Well, it's also telling you there's no point in testing against something for null if it can't be null. So it can help you remove unnecessary code as well.
True. And while we're there, in fact, if you reformat that method a bit, because we seem to have 2 ifs on a line for reasons. You'll also see that little bit of green background there at line 16, now line 15, and that's a smart cast. So the compiler is able to see that we've tested that the result is whether the result is null there, And because we made that test, it can't be null over at the right-hand side there. And so this is called flow typing, and it means that the once you've tested something for null, the compiler is able to infer that you can make safe calls on it, which is really, really useful. Good. Okay, so let's just run that, check that we are all on safe ground before we go on. One day that will then control R. You wouldn't think it was that hard, would you? One other little Kotlin change. If we were to alt enter on leg in is longer than, we can do what's called converting the parameter to receiver. Let's do that and see what happens. So what's happened here is we have created what's called an extension function. And this looks like a method, but isn't actually. So it's just a static function in this case. But it means if you look in line 15, previously we had to say is longer than leg duration. Now we're saying leg is longer than duration. So it makes things read really nicely. And we can do the same thing then with find the longest leg over. We can make legs the receiver. And now from Kotlin, we would call this as list of leg dot find longest leg over duration, which would be nice. In Java, though, we still haven't actually changed anything. So over in Java, our longest leg over tests still call find longest leg over and still pass. So these extension functions are resolved as static methods in Java, taking the thing that Kotlin would normally put on the left-hand side and making it the first parameter. Splendid. Okay, so now we have we've converted our code to Kotlin. What we're going to do is we're going to convert bits of longest leg over tests from using optional leg to leg question mark to a nullable leg, and we can do them in parts as if we were converting bits of our code base. In order to do that, though, first of all, we'll go to longest leg over tests and we'll convert that to Kotlin itself. Looking at this, there are a couple of little warnings in here. If that was to F2. One is Java util list shouldn't be used in Kotlin. Use Kotlin collections list. And what this is telling us, Kotlin maps Java lists to its own lists inside, but it would prefer it if you referred to them as Kotlin lists rather than. And in particular, instead of using list.of, if you alt enter on list.of, in fact, it offers to replace that. That means now that everything, in fact, in here is Kotlin's list as far as it's concerned. They're interoperable, but Kotlin's list is a read-only list by default. You can't add things to it. Run this test, shall we? Now, what we're going to do is called expand contract refactoring. So we're going to add in a thing. We're going to move over to calling the new thing. And then we're going, when we've moved everything over, we're going to delete the old one. And the thing that we are going to duplicate, effectively, have two different interfaces to, is our find longest leg over. So we want a version of this that returns an not optional leg, but nullable leg, but otherwise has the same signature. And luckily, that's the middle of this code, really. So we can take all but line 19 and extract a method from it. And you can see, in fact, the naming is a little bit easier once you have an extension function, because you have an implicit thing that you appear to be calling this on, in this case, list of leg. Having done that, we can then inline bits of find longest leg over. And Kotlin has this nice syntax where instead of having a return statement, you can just put everything into one nice equals like that. Okay, now we have two versions of this function. We're only testing the top one, but all the implementation is in the bottom one. So it's quite safe really to refactor from one to the other. So let's make that public so that we can call it from our tests. Phew. And just before we go on, the conversion to Kotlin has explicitly imported assertions cert equals. So let's alt enter and just sort of get rid of some of those, make it a little bit sweeter. Right. So let's do the first one. We can inline find longest leg over here now because it's in Kotlin. And when we do, we can see that what we're doing here is we are checking that wrapping something up into an optional is the same, will give us optional empty. So we could unwrap both of those, and we have to do it by hand, irritatingly, but effectively we can say that this is assert equals null. What happens when we call the Kotlin code? So let's run that. Splendid. And then we can just make that assert null. In Java, IntelliJ notices that those are the same thing and offers to convert one to the other, but not in Kotlin yet. So we've done one of these, which is good. It was an easy one. And we're gradually going to work our way through all of our Java code. Well, what was our Java code? Converting it over to Kotlin. And then converting it from the optional returning version to the nullable returning version. That's quite easy in these two cases. So even Nat has managed to do it. It's very hard in these webinars with absolutely no reaction, isn't it? It's very quiet here.
A bit like when you normally tell a joke.
They laughed when I said I'd be a comedian. They're not laughing now. Right. So now we're going to the harder cases. And in order to convert those, first of all, let's have a look at what happens. Let's first of all recap on what it is we're doing. In this case, we are calling something that returns something that might not be there. And we're saying, oh, it actually has to be there. And or else throw is unwrapping our optional and saying, if I couldn't find something, I'm going to throw a pointer, an exception. And if I could find it, I'll unwrap it so you can call .description on it. So what we're going to do, no, don't do that. Don't do that yet. So what we're going to do, first of all, is we're going to find out how this fails. So let's make that plus millis just to see how the Java code would fail. In fact, ironically, we're not really testing our code now. We're testing the way that we're handling optional. So it turns out that or else throw in Java throws no such element exception. That's fine. It's just the way it's defined, and it's a way of thinking. It really means that Java developers were thinking that optional was effectively a list of nothing, rather than a nullable thing, if you like. Okay, so leaving that failing, let's go and inline legs find longest over. And now, what are we going to do with this? Let's remove the optional of nullable altogether. In these cases, note we're actually unwrapping our optional in order to call something on it. And so we should just be able to remove the or else throw. But if we do, you see the compiler complains and it says, you can't do that because longest leg over is returning a nullable thing, and it might be null, it might fail. So you can't just go ahead and call description. So how can we fix that? One way we can fix that is a thing called the, well, what's it called? We call it damn it operator, bang, bang. And if you
Non-null asserted according to IntelliJ.
okay, well, this is the non-null assertion operator then. And if we do that and run it, bearing in mind that we've broken the test in order to see what would happen if this isn't there, you can see in this case, the non-null assertion operator throws a null pointer exception. That's all right, slightly different than the Java code, but providing you weren't relying on Java code catching no such element exception, that's a safer way of bailing as the Java was. We don't really like the damn it operator because it just converts something to an exception, but maybe okay in tests. A better solution though is the null safe call operator. I can't remember the name of it. Question
Null
mark
safety
dot.
reference.
Null safety reference operator. So let's put that in there instead.
In here?
Yeah, in there, yes. So if we use that and run the tests, what the null safety reference operator does is it only invokes, it only tries to dereference if the thing on the left-hand side is not null. Otherwise, it just keeps null. So in other words, now we're not getting an exception that we couldn't call description. We're just that expression is returning null, which may be fine. And in fact, in this case is good because we're comparing one day and we're getting null back. So let's leave that as it is. That's a good way of doing things in tests, but it's only really passed on the problem of null. But in this case, it's passed on the problem to our test framework. So make that minus millis, so our tests will pass. Good. In this next case, we're doing a more typical thing of substituting an actual value when we didn't have an optional one. So when this fails, and let's make it duration of minutes 59,000 or something. In this case, you can see instead of pulling out the legs description, we end up with calling the or else found. So let's go ahead and inline find longest leg over, and we'll look at the Kotlin equivalent of that. And again, unfortunately, no easy way to do this rather than by hand. So the Kotlin equivalent of .map in this case is question mark let. And in fact, we can just take that leg.description in there. We don't even, we can take the method reference. That's the one. So question mark dot was our null safety reference operator, and let is a special form in Kotlin. It's actually just a plain function actually, but that pipes its left-hand side into its right-hand side, really. So it's equivalent of map from this. And then or else we have a thing called the Elvis operator, called because it looks like Nat's quiff. And in that case, the Elvis operator does the opposite of question mark dot. It it evaluates its right-hand side if its left-hand side is null. So the net result of all this is exactly the same as the Java code. So we get no leg found, and if we return this to its 59 minutes, we'll be back to passing tests.
And we can simplify this even more, right? Because question mark dot let and then calling something on the thing you pass in can be just written as that.
Yes. As now we'll demonstrate by actually running the test.
And then probably like that.
So this has got to the stage where we've simulated really having converted all of our clients of legs from Java to Kotlin. So if we go back into legs, then we see that find longest leg over is now unused, which is splendid. So we can delete that. And this is the contract stage of our expand contract refactoring. the nice thing about expand contract is it means that you can keep both versions in the code base. You can be in the middle of an expand contract refactoring for a few days or even sometimes a few weeks, but keep everything up and running. You don't have a big bang problem of I've got to finish this before I can check it in. And finally, while we're here, that file JVM named legs, now we don't have any Java clients, so that's now dead to us. Splendid. How are we doing for time? Oh, we got some time. Good. So we haven't yet really tackled. So we've tackled sort of how to migrate from optional to nullable in a code base gradually, but we haven't really had much fun. So we're going to have a little Kotlin fun now and try and make longest over a little more idiomatic Kotlin.
And that's typically what you do. Like you would introduce Kotlin into part of your code base with the intention of refactoring it into shorter, more concise, more safe code to take advantage of Kotlin's features, because that's the code you're working on right now. And you still want to keep all the code that you're not working on as unaffected as possible.
Now, personally, I mean, I wrote longest over, and I wrote it a little bit pathologically, imperatively, but I have trouble knowing. I mean, I had to write the test in order to know that this works. I certainly can't look at it and say that this is code that what this code does or that it works. So we're going to try and make it more expressive using Kotlin. First thing we can do is to take a look at leg is longer than. There's a little squiggly line on there, and Kotlin allows you to use operators. In particular, it maps operators into comparable. So you see that there it's saying you can alt enter call replaceable with binary operator. So we can replace that with greater than, which makes that a lot easier to see. And by the time this is just plan duration is greater than duration, I don't think we need to give it the name is longer than, so we can just inline that. So that's nicer, shorter, and so on, but still the form of it is the same. It's still iterating over all our legs and doing some calculations that make my brain hurt a bit. Haven't found a good way of refactoring from that to Kotlin, but what we're going to do is we're going to re-implement this from the ground up as if we hadn't started in Java, and then see what that would look like and different forms of it in Kotlin. So we have a list of leg and we're looking for the longest over a duration. And the clue there to some sort of algorithm is that the longest over, well, there's only one longest over. So let's find the longest of the legs. And we will create a, well, that's just going ahead, go on, Billy Boots. So Kotlin has a max by on null that allows you to find the maximum value in a collection by some property of the items in that collection. So in this case, the property of the item in the collection is the planned duration. And note that it says or null, which gives you that clue that we had in the first place, that what to do when the collection is empty. Well, it's telling you that might be empty by saying not only this is max by on null, but also, yeah, longest leg, I think would be a good name for that variable. And if you ask Kotlin to specify the type, you'll see, so it's not only telling you or null, our naming convention thing, but it's also returning a leg question mark. Okay, so let's just write now what we want to do with that thing. Let's say when when longest leg is null, we want to return null. When the longest leg is longer than, its planned duration is greater than duration, we want to return the longest leg. Otherwise, we want to return null. And that's sort of from first principles what this method does. We think we've got reasonable tests and they pass, which is all good. Note again on line 9, that green stuff that's telling us that our when statement having only one of these branches can ever be entered, and they're tested in order. So if you've got to line 9, it's saying got to line 9, we have to pass through line 8. We have to know that we know that longest leg is not null, so we know that that planned duration is now a safe call there. If we alt enter on one of the returns, I think we get this form, because when is an expression, and the result of the expression is I can't point to the screen, but either null or longest leg in this case. Let's run those tests. This is my favorite expression of this. It's not too long, it's not too short, but it's too long for Nat. So what we're going to try and do is get rid of this sort of irritating local variable. And we are going to do that with our let that we looked at before. And there's a little trick here. What we're going to do is we're going to say .let, and then we're going to give the lambda parameter the same name as the put the braces. Oh yeah, well, something like that. Yeah. Does that actually work?
Only one way to find out.
So what we've done is we've created a block, and we've actually moved the thing that was using our local variable into the block, and let has piped, slow down, let has piped the left-hand side, which is this max by or null, into its right-hand side, and given it the same name. So we can then, as Nat suggests, delete that unused bit there. And we can move the return out, and we have to do that by hand, irritatingly. Okay, so that's removed our local variable, but we're still left with testing for null. But we know that question mark.let did that for us. So if we just change that to question mark.let, then again, the compiler is smart enough to see that in fact longest leg can't be null here, because question mark.let wouldn't allow that through. So you can alt enter on that to simplify it. Unfortunately, you can't then actually, I think actually alt enter on the when does it. So you got to when and say simplify that.
Very nice.
That leaves us with this slightly shorter expression. And because it's now a single expression, return this, we can alt enter on there to convert that to an expression body. And I think that sort of format, I might even join lines 6 and 7 together personally, and then reformat. Boom, and then run tests. So that is a single expression. It's okay for Kotlin. I think most Kotlin teams would probably be able to read that and work out what it's doing. It's still not short enough for Nat, though, who is, I don't know what pathological it is. So what it's actually doing here is max by or null, and then there is a conditional inside our when statement. And Kotlin has a special form called takeif, which is effectively doing that all in one go. And again, when I say special form, it's actually just a function in the Kotlin standard library. And Nat is going to explain what it does, because I'm rubbish at it.
What it does is take a value on its left-hand side and a lambda anonymous function on the right, and it passes that value into the anonymous function and returns it if the anonymous function returns true. So it basically tests the value that you're applying takeif to, and if the value is true, and if the test returns true, it keeps the value, takes it, and if the function returns false, it discards it and returns null. Exactly the when expression we saw earlier, but as a standard library function. And we can simplify it shorter by saying, here we go. I think that is the shortest and most declarative description or definition.
You could convert the it.plan duration to a method reference.
Yeah, I don't know if that makes
he
it
doesn't want to go that far.
more or less readable. It doesn't make it any shorter, really. I prefer it in this case. But yeah, there are options, and when you're working in a team adopting Kotlin, especially when you're coming from Java, there's often quite a bit of horse trading to do to come to a team style of code, things that you all find acceptable or not acceptable. And over time, I think people move from wanting to explicitly write out all those different branches of a when statement to wanting to express it in a more concise way using standard library functions. Duncan's just not there yet.
I note, by the way, that 1235, Mark Addison asked, could we not use the Elvis operator instead? I'm hoping that maybe we did use the Elvis operator at 1235 or slightly after it, but hopefully he'll come back to us later on to tell us what we've missed. We have, just long enough, I think, maybe to undo the damage that Nat has done and demonstrate our, it was just what we did. Thank you, Mark. So let's see whether we can undo that damage just with refactoring. And this is, I even have some notes about actually how to do that. How do we go? Let's alt enter on the question mark dot and replace it with an if. So let's run the test, check that we still have the same. Did we run the test last time? I can't remember.
We did.
We did. Splendid. If we inline the let, have you done that already?
No, it just did it itself. No, because we turned it into a take if.
Right. Okay. Let's inline the take if as well. And let us reverse the state that if, yes. And now
this one, you want to flip it?
Yes. No, not that one. It's alt enter on the if, I think, which is invert if. And now replace that with a when. And we're back to sanity. Okay, I think it's now 10:02. That gives us time for questions from what is quite a silent audience out there from our perspective. I hope you enjoyed this. Nat, what did we learn?
I think we learned that Kotlin has language support for null, which not only does it have null in the type system, which can detect errors, it has flow typing, which means that it makes working with nullable types more convenient than they would be in a language without flow typing, like Java. And it has special operators for working with null so that your code is very concise, and standard library operations that are also there to help you work with null, either discard things and get back a null, or keep things and not have a null, and so on. There are naming conventions across the standard library that let you know whether something will return null or not, but the type system also is covering your back. And we can refactor very gradually from Java to Kotlin, keeping the code base running with both languages, continuing to add new features in either language, but slowly taking more and more advantage of Kotlin features as we go to get faster and faster development.
We've learned that programmers can reasonably disagree about what the most concise readable form of an algorithm is, and if you want to see that taken out in a book, then you should buy Duncan and Nat's book.
Most of it is agreement, but we do highlight where there can be differences.
Splendid. Ben, I think we're done.
Thanks very much, both. There was one question in the box about in terms of developing marketable skills. do you think Kotlin is becoming more popular in the professional world? Definitely is. Do you think it will catch up / overtake Java in the future? So I don't know if you want to give your 2 cents on that, folks.
It's overtaking Scala now, I think, quite comfortably. It's got a very, very long way to go before it gets anywhere near Java in terms of developer mindshare. But it's here to stay now. I think definitely the adoption for Android by Google meant that there's no risk to adopting it. It's now I'm seeing it used a lot in server-side development as well. So I think it's here to stay. Whether it gets quite the adoption of Java, well, we can hope.
I mean, one thing that it would be easy to say you can't really overtake the horse that you're riding on, and in some ways Kotlin is riding on the horse of Java. Certainly on the server side, we are relying on a vibrant Java ecosystem to be there in order that Kotlin server-side Kotlin works. But it is also there in JavaScript, it's also there in native. So JetBrains are pushing those things. I think it's a certainly more compelling native story. It's possible to run, compile Java to native, but it's a more compelling story there. I don't expect it to get as big as Java, but certainly for us, the ability to leave, maybe 25% of your code base in Java, if you start 100%, that's a perfectly reasonable strategy. I don't think we want to kill Java. We want to use it to boost us.
Yeah, makes sense. And in terms of marketable skills, I think there's no doubt at the moment that if you're a experienced Kotlin developer, there's some pretty good rates and salaries on offer out there. As Duncan and that probably know by the multiple LinkedIn attempts I make at them each week. I think it's definitely going in the right direction, and some pretty serious clients are now starting to use it for server-side projects. So definitely worth getting stuck into, in my opinion.
I see in the chat that Mark says there are too many good quality Java libraries out there to replace, and I think that's certainly true. One thing we have found, though, is that Kotlin is very good at wrapping Java libraries to make them a bit more communicative, a bit more expressive. I mean, lots of the Java libraries tend to have sort of irritating builder pattern things to configure them and so on. So the combination of a small Kotlin shim on top of a good quality Java library, I think, is really powerful.
Yeah.
Cool. I think that's all the questions. So yeah, really appreciate your time both. And thanks everyone for attending. If there are questions that didn't come up now, then feel free to ping me and I can hound Duncan and Nat to answer them for us. It was recorded as well, so if you kind of had to dip in and out or anything like that, or want to have a go again and make some notes, then just drop me a message and we can get that across to you. There is one more question actually. If
there is.
Yeah, go on, you can see it, so I'll let you answer it.
Michele, is it? Can you comment on Kotlin's performance versus Java? This is an interesting question. I think to the extent that it is running on the JVM, you can write code that is as performant or as not performant as your normal Java code. It's our experience that in some of the areas where we might have to really use Java streams to represent things like map and reduce over collections, that Kotlin can be considerably quicker than Java, because streams, thunking in and out of streams tends to be a bit clunky, especially for small collections. If you have large collections, you can still use those stream operations. You can still use streams. So my experience is that I have rarely written Kotlin code, even naive Kotlin code, that ran slower than Java, and it often gives you opportunities to write Kotlin code that is quicker than the Java, or at
There are
least
a couple
code
of,
that's understandable and quicker than Java.
yeah. Also Kotlin, because it's got much lighter weight lambdas and has better support for functional programming, there's much less need to use reflection. And if you have underlying frameworks that take advantage of that, you know, your ability to start up is much quicker, and any code that would otherwise use reflection is, you know, just using compiled code and check to compile time, so that's much faster. It also has inline functions, so those get compiled into the call site, so there's no function call overhead, and that allows the Kotlin compiler to make better allocations of local variables and eliminate, you know, actually eliminate the allocation of objects in some cases. So, and it plays nicely with the hotspot. It does mean your functions get bigger, but on the other hand, higher order functions, our inline functions, can be significantly faster than Java in tight inner loops.
Cool. Thanks so much. We'll wrap it up there, but yeah, do follow up if you've got any more questions, and I'm sure Duncan and Nat will be happy to help us out.
Splendid. Thank you all.
Thank you very much.
Cool.
All right.
See you later.
Goodbye.